In Algebra 1, Section 9.1, we're dealing with geometric sequences. So basically, a geometric sequence is a pattern, but it's a pattern with ratios. So the ratio of the successive terms are the same. For example, if I have 1, 3, 9, 27, this is a geometric sequence because if I go from 1 to 3, right, the ratio is 3. 9 divided by 3 is 3. 27 divided by 9 is 3. So it's multiplied by 3 every time, but it doesn't have to be multiplication. It could be, well, it can. It can be multiplied by a fraction, but no matter what it is, the movement from one to another is the same ratio. Okay? So with that, if I have a geometric sequence, then I can figure out, once I have the pattern, or at least, the first few terms, I can figure out with this equation right here, an equals an minus 1 times r, any of the future terms. So n is the term, and r is the ratio. Okay? So, oh, sorry, I think this is supposed to be, oh yeah. Okay? So for example, number 1 wants us to find the next 3 terms. So, if I go from here, this ratio is 4 to 1. This is 4 to 1. This is 4 to 1. 64 divided by 16 is 4 to 1. So that means my next one is multiplied by 4. So, grab my calculator. 64 times 4. So this is by 4 over 1 equals 4. 16 over 4 equals 4. And 64 over 4 equals, over 16 equals 4. So that means I do 64 times 4, which gives me, my bad, which gives me 256. And then the next one is 1024, and the next one is 4096. Right? Next one's a little trickier. I do 3 from here. 3 over negative 9 equals negative 1/3. And then negative 1 over 3 is still negative 1/3. Okay? Then 1/3 over negative 1 is negative 1/3. And then from here to here is negative 1 over 9 divided by positive 1 over 3 gives me negative 1/3. If you have something like this, you can put it in decimal and it should give you still negative 1/3. So each time it's negative 1/3, negative 1/3, negative 1/3, negative 1/3. Okay? So that means by each time I have to multiply each one by negative 1/3. So the first one, negative 1/9, I have to multiply it by negative 1/3. This gives me positive 1 over 27. That's my first one. Then I have to do 1 over 27 times, again, negative 1/3. This then gives me a negative 1 over 27 times 3. Negative 1 over 81. And the next one is negative 1 over 81 times negative 1/3, which gives me positive 1 over 243. Okay, so those are my 3 next terms. 1 over 27, negative 1 over 81, 1 over 243. So I find the pattern and then I apply the pattern to the next 3 terms. Go ahead and write this down. I have one more board for you. Sorry, there's a mistake on the board. The equation is an, and this is a1 r to the n minus 1. So n equals the number of the term, and then r is the ratio, and then a1 is the first term. Okay? So please correct that on your notes. So I wrote it here. an equals a1r n minus 1. So if the geometric sequence has a1 of 5, so the first term is 5, and it's a ratio of 2, so it multiplies by 2 every time, they want you to find the 6th term. So your so your n equals 6, because you're looking for your 6th term. Your ratio is 2, and your a1 equals 5. So I'm going to plug that in. an, so that's my answer, what I'm looking for. a1 is 5 times r, which is 2, to the n minus 1. So 6 minus 1, which is 5, right? So first I'm going to apply this 2 to the power of 5. Which gives me 32, so 5 times 32 times 5. So that means the 6th term of this sequence will be 160. Now, sometimes they're not just going to spoon feed you the variables. You're going to have to put them together by looking at the pattern itself. So we know from here that they want us the 9th term. So we want to know that n 9, right? We know what a1 is, the first term, which is 2. Now all we have to do is find the ratio. Well, this is negative 6 over 2, which gives me negative 3. This is 18 over negative 6, which is negative 3. And this is negative 54 over 18, which is negative 3. So my ratio is negative 3. Once I get that, then I can do exactly what I did here. So my answer, an, equals my a1, my first term, which is 2, times my r, which is negative 3, and then n minus 1, so 9 minus 1. So it gives me 2 to the negative 3, 8. Right? I'm going to go here. I'm going to do negative 3 to the power of 8. Okay, don't forget in your calculator to put negative 3 into parentheses. Okay, or else the 8 is not going to apply to the parentheses and you might get the wrong answer. So parentheses 8 negative to the power of 8, which gives me a really big number, 2 times, 3 negative to the power of, 6,561. Positive, right? Because, because the negatives, because a negative to the power of an even number will give you a positive. Multiply that by 2. So this got big pretty fast. 13,122. So that means the 9th term on this sequence, if you keep going, will give you positive 13,122. Right? So, hopefully that made sense. Go ahead and write this down. Try page 621, numbers 4 and 6, 621, numbers 4 and 6, and I will see you in class.